Hey y'all, it's me again. Here we are in our next section of section 10.2, areas of trapezoids, rhombuses, and kites. Got a little bit of a shadow right here with this, with the overcast sky. So, I know there's questions regarding homework. Hold off on it. Just hang on to it. I understand. Trying to keep the homework a little bit light. Hang on to it. Don't lose it. But we're gonna, Lord willing, I'm gonna have a Zoom on Tuesday next week, and we'll kind of collaborate and discuss homework then. So just keep it, hold on to it, keep working hard, keep doing. All right. I know you can do it. Encourage you guys. This is fun stuff for me. I love it. Okay. So we've got trapezoids, rhombuses, and kites. I want you to take a look at page 729. You can pause the video and take a quick look. This is fun stuff. Just take a look at it. You don't have to do anything. There's nothing. Just have a look at it. This is a simple construction of what's going on, of how these formulas came about. Okay. So early mathematicians played around with paper and cut them, maybe tangrams, and so we have area of a trapezoid here. Formula is 1/2 height multiplied by the sum of the bases. Okay. So remember, the bases are the parallel sides. A trapezoid is a quadrilateral with two parallel sides. So base 1 and base 2, or base 1 and base 2, doesn't really matter. Okay? I jokingly say I got to make sure I have a square corners, or else I'm going to have a trapezoid for soccer. Okay? When I paint the lines. And this is an example of if I didn't have square corners, I don't have square corners here, then if these two lines are parallel, because of the goals like maybe here and there, but it's still a trapezoid, and still be not a correct soccer field, because soccer field's a rectangle. Okay. Area of a rhombus is by the equation 1/2 d1 times d2. So that's area is diagonal 1 multiplied by diagonal 2. Okay, connecting the vertices, the opposite vertices, and amazingly, the formula for a kite. Okay, difference between a rhombus is all sides are congruent. With a kite, adjacent sides would be congruent. All right. And so, but the formulas are the same. That's pretty cool. Take a look at page 729. Now I'm going to go ahead and work through these real quick. So let's look at number 5 on page 733. You've got a trapezoid that's upside down relative to us. It doesn't, I mean, there's really no, and so number 5, it looks like this. Okay, and so this one's pretty much straightforward plug and chug. It's got a 4.8. I'm looking at your book here, 7.6, and it's got a height of 5. Okay, this is straightforward plug and chug. Area equals 1/2 multiplied by the height, which is 5. How do we know its height? It's got the perpendicular line there. It's got the right angle there. Multiplied by the sum of 7.6. Oops, I'm running out of lead. 7.6 plus 4.8, and plugging that in my calculator. Can't see the decimal place there. Plugging that into my calculator, I get 31 units squared. Okay. So when in doubt with area, always provide units squared if units are not provided. Okay. I'm gonna move quickly on. Number 10 again is same thing. It's plug and chug. Look at number 10. They tell us diagonal 1 is 10 and diagonal 2 is 19. Multiplication is commutative, so certainly could have switched those. In fact, I'll go ahead and do that on purpose. 19 and 10. Diagonal 1 and diagonal 2, 190 divided by 2 is 95 units squared. Okay, so again, total plug and chug. Messed up the thing, and using these formulas. Okay, no algebra that needed to be done. Solve for the variable. A is already solved. That's what we're looking for. So I just plug in the values. Now we're going to do a little bit differently, where I want to use algebra and solve for the missing variable. I love algebra, so we're gonna unpause the video and set this one up. Okay. So get ready. Okay, so this next one is another trapezoid. I'm going to go ahead and make sure tell you the trapezoid by putting in those symbols there. Okay, yay, trapezoid. All right, so we've got a little problem here because we have this whole length is x, this whole length is 10, and I got this. This doesn't help me, okay? I don't have the height. I also don't have x. Uh-oh, I got 2 unknowns, but they told me area. Okay, that's good. So, but I can't, what I want to find is x. X is going to be, I'm going to call it base 2. Okay, x is base 2. That's base 1, base 2, and I don't have height. No problem. I can find height because they gave me this. So I can draw an axillary line here, and I'm going to go ahead and do that. So I can draw lines in. I'm forcing this to be, now I've got this little rectangle going on here, but more importantly, I've got a right triangle. And I know you know something about right triangles. You know that's 60 degrees I can set up. And I'm going to go ahead and let this be y. Why? Because you got the hypotenuse and h and height and stuff. So sometimes I don't always let the h be h because of the hypotenuse situation going on. So I'm going to let it be y. All right. Now some of you should already know what this value, this length is and can already find the answer. So if you're savvy with your 30, 60, 90 triangle. Okay. But I'm going to go ahead and set this up and say sine 60 degrees in reference to angle 60, opposite and hypotenuse. That's why I chose sine. Some old horse. Okay, so opposite is y over 2. Y is going to be equal to multiplied by the sine of 60. And plugging that in my calculator, that was approximately 1.73. 1.73 actually turns out to be the square root of 3. Okay, so I'm going to use decimal approximate still, but this is square root of 3. Remember, if you remember this is 60, 30, 90 triangle, if that's 2, that's radical 3, that's 1. Okay, so I'm going to tell you what the answer is right now just based on that knowledge alone. This is going to be x plus 1. Well, x is this, or not x plus 1. This is going to be 10 plus 1. So the answer is 11. But I'm going to prove to you here that I found the height being that, and with the area being this. I'm going to show you, because I want to also show you the skill of solving by variable. Okay, so I'm going to set up my equation. So area equals 1/2 height multiplied by base 1 plus base 2. All right, algebraically, I'm going to get rid of this fraction. All right, I can do 2 for 1 if you guys algebraic savvy, do more than one step. But always make sure you're doing the correct algebraic step. I'm going to multiply both sides by 2 to get the fraction gone. Okay. Because why did I multiply by 2? Because 1/2 multiplied by 2 is 1. Okay. So I multiply this side 2 and this side of the equation by 2, and this becomes a 1. Then I'm going to divide both sides by h. You're savvy enough that you don't have to show it anymore. So I'm going to divide by h and divide by h. So 2a over h equals b1 plus b2. Get used to the subscripts, guys. Subscripts are going to be from here on out. This is base 1 and base 2. These subscripts are part of math. It's part of language. Okay, final step is I'm going to kick b1 over to the other side. I'm going to just subtract b1, and there we go. Okay. So, next we're going to plug in the values, and I'm going to show you that the answer is 11. So I have 2. Area was 18.2 from earlier. All right. Divided by, what was the height? It was 1.73, or it's a decimal approximate, a square root of 3, minus base 1 was 10, and that's base 2, and plugging that into my calculator, let's see, 2 times 18 point, got my calculator here, 18.2 divided by 1.73 minus 10 is indeed, it's going to be 11.04. Okay, because of rounding. Okay, it's not, we didn't use exactly square root of 3, we rounded. So indeed, that is 11.11 units long. Okay, so we were given area, and then we wanted to find a certain length. In this case, base 2. All right, got one more problem to do, and then we'll be done. Okay, once again we have a problem where we've got a shaded region and a non-shaded region. We want to find the area of the shaded region. So, you know, my excellent shading skills and drawing skills going on here. Okay, and this is obviously the non-shaded region. So we want to know the area of the shaded region. So this is going to be typical from here on out. We've got, I'm going to write just TA, total area, is going to be area of trap. Area of trap minus area of triangle. Okay, so this is general setup, and I want to see this. I want to see this in your work. This is super important, because if it all else fails, you make a mistake here, I still got the work going on. All right, so I know the formula for area of trapezoid: 1/2 base 1, or excuse me, 1/2 height multiplied by base 1. The problem is sum of base 1. Let me. I'm digressing here. I'm looking at the cloud note. Okay, so base 1 base 2? Well, with all these little happy hash mark things here, I know that this is going to be 6. Okay? And so then, with this being 6, and looking at this, and if this whole length is 20, and if these are congruent, then these have to be 10 and 10, which means that these have to be 10 and 10. Okay, how does that help me? Well, we'll see. Okay, we at least know that we have base 1 and base 2, but we don't have height. We've got 6, but we don't have the total height of the trapezoid. And for the triangle, we have the 1/2 base times height, but we don't have height. Okay. Once again, our awesome skill of drawing an axillary line here, and I can draw this in, right? And I can create a right triangle. And since I'm going to put a triple thing here, I'm purposely splitting this, and then I can split this right down the middle and draw it. Because this is an isosceles triangle, this is how I know that it goes straight to the vertex, okay? This only works because this is an isosceles triangle. I know this. This is from previous work that we've done, okay? So that'll make this 3 and this 3. Well, if this is a right triangle, then I've got hypotenuse squared equals the sum of these two sides squared. So h squared plus height squared plus 3 squared is going to equal 10 squared. Okay, so 10 squared is going to equal 8 squared, which we want to know height, plus 3 squared. Okay, working that out, I've already done that for you. 9.54 because I'm running out of time. All right, so now I have height. Okay, I'm going to plug it all in. So up here we have 1/2 times h is 9.54. Let me get my fat fingers out of the way. 9.54. We've got 20 plus 6 minus 1/2. Can't write straight today. 1/2 multiplied by base is 6 multiplied by 9.54. Okay, a little bit not doing well. Okay, so my writing skills are going as I'm watching the clock go down. So punching these values in, I got 124. You can do this all on your calculator. Minus 28.62, and then total area should be 95.4 units squared. Okay, to review, you've got this big structure here, and the key to doing these things is don't even think about the numbers, don't even think about those, think about the hash marks, that's totally fine, but always think about this. What is the total area going to be? Oh yeah, this big structure is a trapezoid, I know that. So area of a trapezoid minus the area of the triangle, okay? And then you may look at it and go, I don't have enough information. Well, that's geometry teachers are like that. We give you the bare minimum information that you need to solve. You often have to draw an axillary line or remember something that you knew. Since this is an isosceles triangle, if I drew this down, this is a perpendicular bisector going on here. What? That's all the information. I don't remember any of that. Well, too bad. Just kidding. But not really. Okay. So here is that's the last problem we have to do. So work hard, study hard, and talk to you later. Okay, bye.